and sign into your calculators if you haven't already. All right. Make sure your notes are out, open to page 17, and we need to make sure that everybody is signed into their calculators. We're going to hopefully get through the notes today and hopefully do it rather quickly. There's some of this is a little bit conversational. You have to sort of, we'll say this has more real-world applications than most of the things that we do, especially for you as you grow up. There's some like common sense things in it. Particularly you have to like play out a real-world scenario to see if this makes sense. The first thing, though, that we're going to do is, and you can see this question. Now, there's been a total of like 50-ish questions asked by the state on our two new, this Common Core type Algebra 2 exam. If you go through and pull the questions, 6 or 7 of them have related to this topic of exponential growth and exponential decay. So let's start off and look, and we can do most of this. From your work the other day, did we miss class and you had to watch? Was that right? Yeah. Okay. So coming in, you should know your exponential growth and decay models. Exponential growth, who remembers what the formula for exponential growth is going to be? What? Who remembers that's what our growth is? You can tell me what our decay would be then. Seriously, 3 people? Wow. Wow. Maybe a lot of people didn't do what they're supposed to. Yeah. There you go. So if it's growth or decay, all you're doing is raising it to the time power, which tells you sort of how many cycles it's running through. So if it's done yearly, the t would be in terms of years and so on. Now, our first question up, this is where it gets a little awkward. And they've changed it and made it a little bit more rigorous, but not that much. Looking at this question, read out what's there. We'll start off with that. Read out the questions there. It's the same one that's on your page 17. Looking at what's there. This is going to be an example of either exponential growth or decay, because you're growing a certain percentage year over year or time over time. Which one would this be? Would this be an example of growth or decay? Hands up, please, if you can tell me which type of situation this is modeling. What do you want to say? This is going to be exponential growth. So I would go through and write that out so I know this is exponential growth. Because there's going to actually be even more formulas relating to this that you have to know after today. So it's really important to be able to correctly identify what's happening and what's being described to us. Looking at what's there, we've got this exponential growth, which means my model normally would look like this. Y is going to be equal to, in this case, A, 1 plus R raised to the t power. Now when we're doing this out, it says if this trend continues, which expression could the CFO use to approximate their monthly increase in revenue? Now, here's what we need to pick out of this. It's twofold, but looking at this, Mickey, what's one thing that you can fill into this equation right now? The 0. What? No, we wouldn't have a 0.81. Who can tell me, please, that we would go through and be able to plug in to this question? 3 of us? 4? And what's that going in for? So we don't know what the initial amount is, but we know that with our rate there, it's 1 plus 0.052, is it 525? Raised to the t power. So we can even condense it down to be this. Y is equal to A, 1.0525 raised to the t power. You should immediately identify this, and if you're on your game and you did the work that we missed, this is going to be exponential growth. Why do you know just from looking at this that this would be exponential growth? We've got 340. We clearly identified it. Those of you who didn't watch, I don't know what to tell you. What do you say? What's the it?
The r plus 1.
Yeah, the base there. If the base value is greater than 1, then it's growth. If it's between 0 and 1, it's decay. This is going to be growing, and furthermore, from looking at this, especially as enriched students, you should be able to see multiple. If the base is 1, it stays the same. This is going to be growth because it's more than 1, and what percent growth would it have if I'm looking at this? If this is my base, what percent growth would I have? 5.25%. This doesn't need to be copied down, but for those of you who didn't do your work, maybe this will help. Who can tell me, please, if that's growth or decay? Let's start off with that. Look at the base. Is that growth or decay? We've got 3 people. What? Growth. Who can tell me what percentage of growth this indicates we've got? What percentage of growth does this indicate we've got? 8%. 8%. Now let's go, by the way, and let's piggyback off of that. Let's say instead of this, I give you this. Is this growth or decay? Hands up, please, when you can answer. Okay? Who can tell me what percent decay we have every year or every iteration? 18%. It's always 1 plus or minus whatever that rate is. Now here's the problem though with what we have based on our model here. Something's different about this equation that doesn't match up to this one. Does anyone see how this equation is different than the one that's up there?
They're in different places. Would you like us?
No, but thank you very much.
Are you sure?
I'm quite sure. You know, we had the Secret Santa breakfast this morning.
Food.
Breakfast pizza.
You know what?
You don't care.
Bought my breakfast.
Food, Mr. Sick. You went and you hung out with the Thomas people?
Because I needed to get something from
There's
the
a door right over on the
Don't
side.
touch me there.
There's a
Are you
door
gonna
right
stop
over
down
on the
there?
side. Yes, I want to see. Oh, it's there?
Behind
Oh, I'm sorry. I'm sorry. That's why I didn't know. It should have. Looks like you hurt my car. Get out of my car. Go to Thomas. Now, something doesn't match between our model and this, what we've got so far. And as enriched students, you should be able to pick this off. How is this model that we've got not representative or different than what's being described? Something in here doesn't match up. What do you want to tell me? What was your guess?
Well, that was 5.25 over a year, and the T was well, maybe it's representing months.
We need ours to represent months, and this is why so few students got this question right when it was first asked. Less than 25% of the region students got this question right, which means a blind guess would have been more accurate than what they gave. Because they rushed in and said it's going to be choice 1, and it's not, because they're not reading for meaning. You have to go through and do this little bit of minor analysis. It's this over the previous year, and now it wants the month. So do you read for meaning? Now, let's ask ourselves this. Does anybody know how I could go through and get my yearly rate into a monthly one? Does anybody want to guess as to what I could do? And if you're, yeah. Close. Well, yeah. I'll say this. I need to figure out how much that rate is per month, okay? So, we'll say this. Go into your calculator. Fine. I'm assuming you've all signed in. Take 1.0525 and divide it by 12. And you're going to see something in there. All of a sudden, our R value is it's decay, so that's not going to work. But he's close. Yep. Try dividing the percent by 12. So take 0.5 0.0525, sorry, 0.0525 divided by 12, and what's that going to give you? Now, is that what we have now? And the answer is going to be no. This is only at 0.43, and we've got 0.27. What you need to understand is this. I need to take my rate and account for the fact that this is occurring monthly. So, how much of this rate are they getting every month? Because our equation is based on a yearly rate. How much of this rate are they getting every month? 1/12. So let's go through and raise this to the 1/12th power, and let's see what we get. Go in right now, please. Take your base and raise that out, please, to the 1/12th power. Who can tell me, please, what that value is now, what your growth factor is going to be? Hands up, please, when you can tell me.
1.00427.
So what did you have to recognize? There wasn't congruence in what your measurements were. We were looking for, or we were starting out and measuring things in terms of what units? What were our units to begin with? Years. We needed to make it what? Months. So we needed to take 1/12 of the rate and raise it to that power. Now, this part always ends up being a little bit of an interesting conversation. We're going to talk about different banks and how often they compound interest, and we're going to derive a formula to see how that works out. But we'll say this to you nicely. You all need to know this because this, we'll get to one of the reasons why this example isn't the best. But if you're going into finance, and I can assure you the people that go into finance make a profound amount of money. There's a former Schrader student that I had on tennis. He went and got an internship. He was just a regular Enriched student. He ended up getting into NYU and got a summer internship at Goldman Sachs. And you notice raise your hand if you've ever heard of the bank on TV, Goldman Sachs. Both politicians, they always rail against Wall Street banks. That's the biggest of the Wall Street banks. They literally just go through and they find companies that are going to make money, and they invest in them knowing, and it's pretty much a mathematical certainty if they put money in. It's a calculated risk, but the odds are in their favor. But they're going to make a whole ton of money. And this is a former Schrader kid that was a little, whatever. He ended up getting this internship at Goldman Sachs, and he did a good job. So he went to NYU, studied finance, and ended up getting a summer internship at Goldman Sachs, and then got asked to stay on as a junior. It's the lowest rung that they have there. His starting salary, you might not think, it sounds like a lot, it's not. His starting salary was $200,000, but he was in the middle of Midtown Manhattan, and especially when you travel in that circle, it's not like you can pull up in an old Honda Civic when you pull up to work. So that you have to have a certain look about you. Yes, so we had to get suits that were done by the Adrian Jewels. They're like $3,000 or $4,000. And he had to look nice when he came into work. So $300,000 or $200,000 goes quickly. But the other end of it is, if the company does well, they get a bonus. Okay? And this is a huge Wall Street bank, to the point where both Donald Trump and Hillary Clinton, during the campaign trail, routinely criticized this bank. Because these people know how to make money, and I think everyone can agree, maybe in some cases they don't operate with the most moral authority. Because their bottom line isn't to make people feel good, it's to make money. So this young man that I had, he ended up going through working for them, $200,000 base, and I'm like, God, you poor thing. And I was like, what's it like working there? He goes, it's incredibly competitive. If you have one bad quarter, it's very common for you to get dismissed. And I go, well, what's the benefit? Like, are you going to look to go on? He's like, yeah. And he goes, but we do get some perks for working there. What's your perks? He goes, well, I'm sure you probably read in the newspaper what our yearly bonus was? No clue. 2.4 million. Every associate. $2.4 million end of year bonus. 2.4 million. Lots of zeros. That's 2, then a 4, then 5 zeros. He made more in his bonus than I would make in 10 lifetimes, maybe 20. Okay. It's a profound amount of money. Finance deals with exponentials. It deals with some calculus. And if you understand the math behind it, you know how the game works, you can make more money than you know what to do with it. It's a very, very, very lucrative field. And that's why I encourage all of you to take the only social studies class that's worth anything is econ. Go through and take econ, and you'll be fine. You'll be fine. Now, we're going to start off, we're going to have 2 banks here, okay? John, you're going to open a bank, all right? Anthony, you're going to open a bank, all right? You guys are open across the street. I'm your desired client. I've got $10,000. We need to figure out what the balance is going to be after these iterations. So let's start off now. John's bank is number 1, and John goes, hey, instead of keeping your mattress and your money under your mattress, why don't you come and deposit it in my bank? I'll give you 4% interest done once a year. Sure. Let me see. Let me run the numbers here so I can see how much money I'm going to have if I don't touch it after year 1. So I go in. My rate is 4%, so I take the amount times the rate to the first power. So go in and do that right now. Let's figure out how much money. You're going to figure out my balance all the time. Maybe this will be like The Price is Right. You can tell me where to stand. Who can tell me how much money I'm going to have? Hands up. This isn't supposed to be difficult for you. Seriously, 2 people? Marissa T, what'd you get? All right. How much money would I have, or what would I do to figure out how much money I'd have after 2 years? Hands up, please, if you can tell me how much money I would have, what I would type in to figure out how much money I got after 2 years. Corey? Okay, so this would be 10,000 times 1.04 to the second power. Go in right now. You tell me how much money am I going to have in John's bank of fund after. Do you want to name your bank? He goes, okay. The bank is called I Don't Know. So I Don't Know Bank is doing wonderful. I Don't Know Bank tells me how much am I going to have after 2 years there. Go in and evaluate it out. No Sam today. Connor, what do you say? Now, and by the way, each year that I don't touch it, you earn interest on the interest that you earned last year. So things get ballooning somewhat fast. Now, the second bank, Anthony's going to open up a bank. He's got to do something better than the I Don't Know Bank. You want to name yours? What? Bank is going to beat I Don't Know Bank, okay? Bank opens up, and Bank says, you know what? I'm going to do this. He's giving you 4%, and I'll give you 4% too, but I'm going to compound it twice a year, which means I'm going to give you 2% interest once, and then in 6 more months, I'm going to give you 2% interest again, which means I'd have 2% interest because my overall interest has to be 4% still. But he's going to have 2% interest done twice. How much would I have after 1 year at Bank? Hands up, please, if you can tell me. Boy, by the way, these are terrible banks. What? 10,000 for. Now, by the way, always go back up to that number, highlight it, and hit enter, because sometimes it shortens it. There might be a penny or two that we miss. Now, how could I figure out how much I'd have in Bank after 2 years? How could I figure out the amount? What would I type in to figure out how much I'd have in Bank after 2 years? Seriously? What would you do to figure out the balance after 2 years? What expression would I type in to figure it out? Thomas?
10,000 times 20 is 1.2.
So, do you have that number?
10,844.32.
Now, why would I want to go to Bank over I Don't Know Bank? You tell me. What? I get a little bit more money. So far, I've made $4 more after the first year. Bank is so much better than I don't know bank. But wait a minute, I don't know bank sees all their customers leaving. They go, I don't want them going to bank. That place is terrible. So now I'm going to give them interest quarterly, which means 4 times a year. How can I figure out what expression would I type in to figure out how much interest I would how much interest I would have if the interest were compounded quarterly? It's on there. I think it's February. It's in February. It's on the form. It's on the form somewhere. I think it's on the bottom.
Oh.
Paragraph. What would I type in to evaluate this out? Well,
10,000 times 1.0404.
close. This right now is wrong.
Oh, to the third.
Nope. What's wrong about that right now? Who sees what's incorrect about that? Yep. It should be 1.01 because you're earning 1/4 of the interest 4 times a year, which makes it 4% total. Go in right now. So how much is I don't know bank going to give you? Hands up, please, when you can tell me how much I don't know bank would give you. Go in, type it in. We got 2 people who can type. Fabulous. Megan, what would you say? $406.04. Okay. How much money would I have after 2 years? What would I write out? What expression, Kirsten, would you do to figure out how much money you got after 2 years?
10,000 and then quantity 1.01 to the 8.
Good, because how many times have you earned interest if it's done quarterly after 2 years? 8 times. Good. Go in right now. What's my new balance going to be? Nick, let us know what you get.
$1,828.57.
You said 57. Did I hear that right? Okay. Now, which bank did I go back to? Did I go back to I don't know bank? Okay. Now, you're out there. This point, I can tell. Look at you. I'm such a terrific customer too, and now you've lost me. I don't know bank. And he says, you know what? I don't know bank is giving out interest quarterly, which is 4 times a year. How many times is bank going to give me interest? Monthly, which is how many times a year? 12. So now I would go through and say, well, all right, to figure out how much I have my starting amount, 10,000, and then I've got 1 plus. Now here's where it gets awkward, right? Because my rate is 4%, but how many times are we doing it? 12. So instead of going through and making it messy, let's just go through and put 4% over 12. Now, how many times will I be earning 1/12 of the overall interest in 1 year? 12 times. So go through right now, please. You tell me, what is the balance going to be at the end? Grace, let us know what you get at the end of 1 year. How could you figure out how much money I'm going to have after 2 years? What could I go through and do, Philip, to figure out how much money after 2 years? Because that would be 24 cycles through. How much money am I going to have after 2 years? Hands up, please, if you can tell me that. Yeah, right? Point what, 43?
Yeah.
Thank you. Now, what's happening, there's two things going on that we should realize. What happens to the balance every time I compound the interest more frequently? Hands up, please, if you can tell me. What happens to my overall balance the more I compound my interest? We've got 1, 2 of us, 3. It's increasing. What do you notice, though, about the rate of the increase the more times that I do it? Not necessarily. Take a look at what happened. When I did it from once a year to twice a year, how much more interest did I make? How much more interest did I make? $4. How much more interest did I make when I did it twice a year? Or sorry, when I did it 4 times a year. I made $4 up here. How much more did I make going here? So from here to here was an increase of $4. From here to here was an increase of $2.04. How much was it to go from here to here? Hands up, please, if you can tell me how much that was. We got one person? Seriously? Oh, we're not good. We won't be good at making change. Philip? Now, what's happening to the increases each successive time? Smaller and smaller. But it's still an increase year over year. So now, the next question is, was I at your bank last? Okay, so bank, I got them up. I don't know, bank is still trying to win me back. How many times are you going to give me interest? He's giving it to me every month. Every week. How many times a year is this then? How many weeks are there in a year? Thank you. Now, you're trying to win me back. I'm loving things over at I Don't Know Bank. 52 times a year I get interest. It's terrific. How many times a year am I getting it with you? What do you got for me? All right. Now, what ends up happening is when you get to something like that, the amount starts to be insignificant in terms of money. If you're compounding every minute versus every second versus every nanosecond, it approaches a finite value. So we're going to talk about for this, goes over here. Let's see. Suppose, now we're not going to work with this just yet. The formula you use for compounded after with the frequency is this. 1 plus r over n raised to the n times t power. So that's our start formula. Looking at what's there, take a look at question number 1. Let's make some replacements in. Use the formula above to find the balance after 6 years on $5,000 invested at that interest rate compounded quarterly. So what we're going to do to start this off is y equals, because y is the end amount, we'll start off with the principal. So, Sean L., what is the principal in this case? 5,000. That's your starting amount. And then 1 plus, what is the R value, Riley?
0.06.
Over what is the N value going to be? Marissa D? Careful. It's done quarterly. How many quarters are there in a dollar? There you go. Now, raised to the NT power. So, Anthony, what's the N value? 4. What's the T value? Go into your calculators right now, please, and let's compute out how much money this would become. You're going to go into your calculator, you type it in exactly as it looks. You can kind of let us know what you get, please, when you get it. I don't put an approximate sign, nor do I put an equal sign on that, by the way, because the answer probably continues on after that 0.51. Is that right? So we're going to round it to the nearest cents with money. That's something that always comes up, and it's frustrating from my end. You've got to know money doesn't go to 3 places. It goes to 2. Take a look at question number 2. Find the balance after 20 years on $5,000 invested at 8% compounded monthly. So, John, what would that expression look like when we wrote it out? Nope. Who can tell me what that denominator is going to be? We got 2, 3 of you. 12, number of times a year. Now, what is the exponent going to be? What 2? It's n times t. So, John, what would you have as the n value? And what's the t value? Go into your calculators, please. Insert that amount in, and then let us know what you get for a value. Another thing, for some reason, and some of you don't do, the money sign always goes in front. Some of you put it behind. I'm not quite sure. Like a dollar sign at the end. I don't get that. What's that?
24,634.
Is this what we got? Okay. Make sure you round correctly. Take a look, please, at the next one. Now, this one comes up again. Yeah, take a look right now at 3. I'll actually prompt you for your answer for 3. Let's see. Hopefully, you've all signed into your calculators if you haven't already. Did this get sent out to you or not? Did it click? No?
It did, but then it disappeared.
You can see these questions show up on the reads. You have to know them, period. So, go through. We've got no entries so far. Go in, submit, read what's there, submit which one you're going to be choosing. If you need to work by elimination, that's fine, but do work. We've got no one yet? One person? Got 11. Mhm. 12 of us that can answer this? Not good. Let's see. Seems like there's some grouping that's happening and clustering that's happening around D. Looking at what's there, the first thing I would need to recognize is every 14 days customers payday loan does this. Every 14 days, they get charged 30% interest. In 2013, someone took out a $300 payday loan. Which one can be used to calculate they would owe after 1 year if they didn't make payments? So this is going to be exponential growth, and it's going to be 1 plus the rate raised to the t power. Except our units don't match, because the rate that they're getting charged is applied how often? By the way, this starts off with a 3. What is the, 300. What is their rate going to be? Well, it's 1.3. The rate is applied every 14 days. So at the end of a year, what would the exponent need to be in order for me to compute out what I have? 3 at whatever the year over the time is going to be. The year over the time. That's why it works out the way that it does. Put a big old star next to it if you don't know what it is currently. Now, we'll talk about our continuous growth model. We're going to skip over this. The more times you apply the interest, what happens to the amount that you're working with? What happens to your balance the more times every year that the interest is computed? It's going to increase, but it starts leveling off over time. What ends up happening is this. You get to something, it's going to approach what's called a limit, and we're going to talk about our continuous growth model. Now, and it sort of got to be a little ridiculous over here. How many times were you giving me interest? Every second, and then you decided you were going to do even more and give it every... Oh, you did twice. Well, you want me back. He's giving me interest every second. What are you giving me? Okay, every 0.3 seconds. Now he's back. He's going to... So you see how all this, it's not going to make a difference over the course of time. That's called continuous growth and continuously compounded interest. Where P represents the initial value, R represents the growth rate, and T represents time, A is the end value. Now I do it as Y equals, you can do it as A equals, it doesn't matter. Now we've got some practice questions. A bacterial culture of 10,000 is growing continuously. I immediately see this growing continuously with a rate. What formula does that mean I'm going to use? This PERT formula here. So it will be Y or A is equal to P times E raised to the... Oh, sorry, I didn't say one thing that we needed to say. What's in there that looks different than what you've done so far? The E. You've already encountered numbers like E. E is what's called an irrational constant. Go into your calculators, please, right now. Go into your calculators right now, and what we're going to do is this. Go in right now, please, and press pi and hit enter. You find the pi button over on the left here. Press pi and hit enter. That gives you 3.14 and some change. E is an alternate irrational constant, or another irrational constant. Go in right now, please, and type in pi. Go find that pi button. Now hit the pi button and the arrow back to finding E, which is like 3 or 4 over. Press enter. E is about 2.718 and some change. So when we work with E, there's more than one way to get it. It shows up there. Does anybody see where else the number E shows up on the calculator? Oh, not there. Sorry, that's for exponential. What? There you go. There's an E raised to the x power. Because E is used with exponentials, it's so heavily used. So hit E, and let's square it, let's say. Okay. So it's going to give you a number value, like if you took pi and square it. Let's go through and do this out. Find the population of the culture at the end of day 1. So this is a continuous growth model. We're going to need to make our replacements in. Amanda, what would you say if this is our formula? what would the initial deposit in be? Then we need to take and multiply it by the number e raised to the RT power. What would the rate be in this example? Mickey, what would you say? 0.16 times. What would the t value in this case be? Marissa, t? What do you think? Yeah, because, and notice, by the way, what do you need to make sure matches up before we immediately throw a 1 in there? They both need to be in terms of the same time frame. So if ours is yearly and this is days, we're going to have an issue. But the rate is daily, and we're taking the growth in terms of days. Go in right now, please, to your calculator and type that in. And let's see what it comes up with, because now we're going to get into what an interesting conversation this ends up being. So you go in, and we type this whole mess in, and you get that amount. Now, here's my problem. Oh, was it 10,000? Sorry. Okay. Now, here's where it gets interesting, because we always end up having this argument, and the state has been somewhat ambiguous on it, so I will let you know this. I will say you could list it out as this. Y is approximately that value, and you need to list the whole thing out. But that shouldn't make sense to you because you all live in the real world. Looking at what we've got, if I'm taking and counting the number of bacteria in there, would it say this many? You can't have partial bacteria, so you could either round to the nearest value, or you would go through and say this ends up being 11,735. Now, in both cases, since it rounds down, you don't get that. Because sometimes, like if you do a question, there's one that I remember we were sitting there. It was very frustrating because the answer that from the question ended up being like, it was a question about the population of deer. So the answer, when you typed it into the formula, came out to be like 43.8 deer. And then there are people going, all right, well, let's take the 43.8 with, if they listed it all out as being correct. Who here has ever seen 43.8 deer? You have, Riley? What did that 0.8 deer look like? Oh, just missing one. Just the one. Okay. That's very good, fine. Then we'll let it go. But I sat there and like, just tell me where to go. Show me a picture of 0.8 of a deer. And they're sitting there going, well, it can happen, you don't understand. And so I'm sitting there, and they're arguing it. So I typed in 0.8 deer and went to Google Images to find out if you could see what 0.8 of a deer looks like. And shockingly, there weren't any pictures that related to deer that had 0.8 of a deer. There were plenty of pictures of 8 deer, but none of 0.8 deer. Now, does it round up to 44? Well, at that time, do they have, how many deer would you expect in the field? 43. So then there's this, well, do you round up or do you not? Well, if you're looking at what's there, at time 5, if I stop the clock, I said, all right, count. At 5 hours, they'd have 43. At 6 hours, they'd have 44. But that's not what the question's asking. So again, we'll get into, well, always put some common sense into it. If it doesn't say to round, think about it. If it's money, if it's deer, if it's people, never seen, that was another one that they asked. It was almost like something from The Walking Dead. So it came up with like 101.6 people. So what does that mean? 0.6 was 6/10, and then there's the awkward part of how do you get 6/10 of a person? You cut from the top, you cut going across, or this way, right? And you cut like from the bottom going up, so they would just be legs walking around? Or would you cut from the top down, so like it's right in this area? Or would you go from the side, right? You split, so it'd be an arm and a leg, a little bit more than half of the face. But they wouldn't be able to walk it, it'd be falling over all the time. So it's really, really just an awkward situation. Now, go through right now, please figure out how many bacteria we would have to the nearest bacteria, well, appropriate bacteria, after 5 days. Hands up, please, when you can tell me how many bacteria. Bacterium. Bacterium. Philip? Was it 255?
Yeah.
All right, we'll trust it. Go through and read out question number 2. That continuously means that you're unlocking the PERT formula. So when I do this out for question number 2, Corey, what would you go through and write out?
Y equals 2,500 to the 0.012 times 5.
Did you get a value?
I,
Who can tell me what the value comes out to be? Thomas? Did you get it?
2,654.45.
Questions on that? Is that what we got? Terrific. Now, is there another question that was on there or not? Oh, wait a minute. He's wrong. Who wants to yell? Boy, you should be outraged. And talk about a bunch of lazy Larrys in here. I am outraged and offended at you simultaneously. You should be, read that question. You should be outraged. You should be demanding that I get removed from the room. I'm unqualified. Why am I unqualified? You tell me. I went right past that answer, and boy, I'm dumb. I sat there and looked at that, and I went through, and we're not wrong with what we have down. I'll tell you that much. We're not wrong with what we have down. But you should be offended at what I've done. What? Why? He's absolutely correct. When you read this question out, that's how much interest we've earned. Or sorry, it's asking only for the interest earned. So, let's go through revise. Who can tell me, please, what the answer to that's going to end up being, what our final is? I'm so sorry. You probably were going to say more, right? And I cut you off. I'm sorry. I'm sorry. What did you get?
154.
Are you going to demand that I get removed from the class? And count. Either double. One strike. Thank you. Boy, see? Person seems very forgiving. Very
I
forgiving.
thought Mrs. Miller, you sent her right out, Mr. Matt.
What?
You sent Mrs. Miller right out. Were you not?
No, that's because she went to Thomas. There's some things that aren't forgivable. Now, I want you to get this down before we finish up, and we'll go over what your assignments are for today. Someplace on there, maybe towards the bottom, maybe in the margin of the page, something on here. If you see continuous growth, the formula you need is, remember, PERT. If you see continuously compounded interest, what's your formula going to be? When you see continuously compounded, what should you be thinking about? What about the one where we give you interest with a frequency? Meaning monthly, quarterly. That's y equals p 1 plus r over n raised to the n times t power. And we've got one more to do. What is the formula for exponential growth or decay? Who remembers what that one is? Just generic exponential growth or decay? Who recalls what that formula is? One person? Two? Mickey, what do you want to say? I'm telling you now, at least I would go out on a limb and probably say that at least 5, maybe 3 or 4 questions are being asked about this. And here's another thing that, just so we're all clear on the same page, we get these updates, and I love this. One of the reasons that I get irritated and I get nervous for you is because the state is constantly changing what its guidelines for what they're testing you are. So this came out, just remember this is page 7. This came out, when did this come out? Does it have, and by the way, I love it. They send it out, it just says draft on the background as though it's not finalized, but they send it out to everyone. So we don't know really if it counts, but it probably should. They send us this out and they go, just so you remember, major clusters, which are big idea stuff, count for 51 to 65% of the exam, blah, blah, blah. Now, if you go, the reason why I get freaked out is, by the way, should we go through and know how to solve systems of equations? What shape is that going to give you? What's x squared plus y squared equals 3? What is that? Circle with the center at the? What's the center of this? 0, 0, origin. What would the radius on the circle be? Radical 3. Notice, tasks are limited to 3 by 3 systems. Systems of 3 by... Look at how much they put in about this. So if they're sending us a reminder, what do you think is going to be on the exam? A 3 by 3 system. The other thing that it shows, are we on page 7? No? Understand the concept of a function and use function notation. That means when you plug in x, you get y. But this is one that literally showed up the other day. Includes that. What 2 formulas did they specifically go out of their way to mention for New York State? Yeah. Compounded continuously, the PERT one, and compounded with frequency. They went out of their way in the memo to every teacher to the state. Now, most of the people don't read this. So maybe we can get a leg up on everybody else. But do you need to know what these formulas are? They're literally telling you everything that's going to be on the test. Is there more that's on here that we've done? Log equations, this is trig stuff and everything, and Providence stats. What we've done here. Can you go through what's the cube root of 27? Hands up, please, if you can tell me. What's the cube root of 27? Riley? So, how would you simplify this down? And what's the cube root of y to the 5th going to break down into? You tell me. What's the cube root? Take the cube root of y to the, or x to the 5th. What would that become? Simplify it down. Close. Now, she missed one little thing, but everything else is perfect, and I'm not trying to be nitpicky. I said, what's the cube root of x to the 5th going to be? We were correctly told it's x times the square root of x to the 2nd. It's not the square root. What does it need to be? Cube root. Okay? Well, you see what I mean? I don't want you to get that wrong. Get it wrong now, not later. Is this going to show up, though? Yes. Let's see, what other stuff is there? What's I squared equal to? How can we prepare the children for the Regents exam? I'm sorry. We need to go through and know how to factor a difference of perfect squares. How many of those have we done? 100? A trillion? By the way, notice, they gave you one here. What does x to the 4th minus y to the 4th factor down to? X squared minus y squared and x squared plus y squared. Am I done? No, because this becomes... You're smarter, you're smart. Now, we're going to say this. You got some homework for over the break. Number 1, you've got assessment 28 from last time and assessment 29. Did you all pick up assessment 28 last time or not? Now, I don't know where they went, where the extras went. In any case, here's what you need before you go. Listen, assessment 29, collected when you come back. That's number 1. The second thing is your project. Did we go over the project last time or no? Yeah. So you've got the project. It's posted in Google Classroom. Read what's there. Third thing is there's going to be a Math Excel assignment that gets activated, I think today at like 2:30. And that'll be due probably Tuesday or Wednesday when we get back. Have a great day, loves. You did good work today. Tell your parents you love them over the break every day.